Hello, everyone. We made it to week 4. Hard to believe, right? So this week we're going over the last type of microorganisms. So we've gone over 2 different kind of major groups of microorganisms, and this is going to be our final group. So let's kind of recap where we're at to make sure that we're all on the same page when we enter this chapter. So we have different microorganisms. Let me make sure this is in view. So different microorganism groups overall that we've studied. One of those is our prokaryotes. Our prokaryotes were the first group of microorganisms that we went over. Prokaryotes are going to include bacteria, being the main one that we studied in this case. And we also talked a little bit about archaea. So we have bacteria and archaea. Those make up our prokaryotes. And the main thing to remember with prokaryotes is these are no nucleus. Oop, almost running out of space. So no nucleus, that's prokaryotes. That's what that actually means. And bacteria and archaea are our 2 main prokaryotes. Then, in the next chapter, we focused on our eukaryotes. Our eukaryotes, we had a few different ones that we covered. So with eukaryotes, we covered fungi, and that's like yeast and mold. We also talked about protists, algae, and protozoa. And finally, in our eukaryotes, we talked about fungi, protists, and helminths. All right, so helminths, remember, while in their immature phases, in the larval stages, those are going to be microorganisms, but once they're in their mature stage, they're no longer micro because we can see them by naked eye. So just keep that in mind, but those are going to be the 2 groups that we focused on so far. We had our prokaryotes and our eukaryotes. Our eukaryotes have a nucleus. Now, what these 2 groups have in common are that they're both cellular microorganisms, meaning that they either are a single cell, and that single cell is an organism, or they're an organism that's made up of multiple cells. So the last group that we're going to talk about don't have any cells. These are actually non-cellular. You might be thinking, how is it a microorganism if it's non-cellular? Well, honestly, organism is probably not a good name for it. So these are going to be non-cellular, you could say non-cellular agents, non-cellular particles, something like that. And so when we talk about non-cellular, this is going to refer to something that you've probably heard a ton about lately, and that is viruses. So we finally made it to the chapter where we're going to focus on viruses. So this is going to be particularly relevant when we're talking about COVID-19. So we will touch on how some of the stuff we're learning in this chapter relates to specifically the novel coronavirus. And besides viruses, we're also going to talk a little bit about a few others. One of those will be prions. So similar to previous units where we focused in this case on bacteria. In our eukaryotes, we really did spend time talking about multiple types, specifically our fungi or helminths, but also protozoa, because in all of these cases, they're going to have a major impact on human health. But we are going to spend a lot of time talking about viruses, probably a little bit less on prions, even though prions have monumental effects on human health. There's obviously a lot more viruses to study because you've probably heard about viruses a lot more. That's because there's a lot of them that we can actually look at and study. And so these are going to be the final group that we're talking about related to the different microorganisms in our class. So just wanted to touch base on where we are as far as the different groups that we've studied so far and how this fits in. So we've made it to that last group, the non-cellular, where we're going to talk a lot about viruses. So, viruses. there's going to be a lot of unique properties with viruses. It's going to be different from what you've learned about in bacteria, archaea, our fungi, protists, our helminths. Bacteria are still cellular. So they still have a lot in common, even though there's definitely differences between bacteria and our prokaryotes and then the eukaryotic microorganisms, as you saw in the last 2 chapters. So there's going to be there are differences within those. But viruses have a lot of unique properties because they are really different in how they work. They aren't made of cells. They aren't cells themselves. So that's what makes them really interesting in studying. So let's go over some of the beginning material for this chapter. So first off, when we talk about viruses and when you're reading your first sections in chapter 6, in these sections it's going to be talking about kind of the beginnings of viruses, how we found out about viruses to begin with. And so how it was really discovered that there were viruses was different infectious fluids that had been known to cause disease were passed through porcelain filters that had been designed to trap bacterial cells. So obviously these porcelain filters had small enough holes that they could actually trap the bacteria in the filter. But whenever you had something that was a cell-free filtered fluid that had gone through that filter, and you still had this liquid, this infectious fluid, and it remained infectious, meaning that even when you took out any bacterial cells that should have been trapped in the filter, this liquid that was remaining still had some infectious component. And so that's what proved that there was actually something smaller than a bacterial cell that could still cause disease. Because prior to that, the idea would have been, well, if it's not a bacteria, what is it? And so now we know that there's multiple different infectious agents that could be causing disease, especially when it relates to patients. And so in a lot of your future careers or current jobs, you are probably dealing with patients that may have a bacterial infection or they may have a viral infection. And so that's normal, common knowledge at this point, but that wasn't always the case. So that filterable virus you're going to read about, that's what it refers to. It's just the idea that viruses are smaller. So they couldn't be trapped in the same way as bacterial cells, and that's how humans figured out that viruses existed. So let's go over a little bit more about viruses before we move on. One thing that I want to touch on is the terminology that we use when we talk about viruses. So you've probably heard people say, oh, that can kill viruses, or that's a dead virus, or maybe a living virus. And these terms, while we understand what is meant by those terms, there's probably better terms that we could be using that really reflect the nature of viruses. So since viruses are not cellular, and they're really not considered living organisms, though some people will argue that they're living based on certain properties. Others will say, no, they're non-living based on certain properties. So really what you want to think of is instead of referring to them as alive or dead, we should talk about them as active or inactive. And I think this is also more meaningful because you've probably heard of different viruses that can be dormant at times, and you'll certainly read about some of those in this section. So if we say that a virus is dead, then if that virus comes back to life, is it a zombie virus? So now you're probably thinking of zombie viruses, so I probably shouldn't even go there. But the idea that this virus is going to be either living or dead just doesn't really fit how a virus works. So it's better if we use terms like active or inactive, because those really are going to talk about what the virus is. Is it active? Is it inactive? It's not going to be alive or dead, because it's just not really possible to be either of those things. So I did want to talk about that terminology, just so we're clear. Now, viruses, when they're going to attack a certain cell type, they can actually go for any type of cell. So usually we're going to think about viruses in the way that they impact humans. So they can obviously infect humans and our cells, but viruses can affect literally every type of cell. So viruses can infect plants. Viruses can infect fungi, protozoa, algae, and even bacteria. So bacteria can be infected itself by a virus. So I think that's a really interesting thing as well. So don't think that viruses only affect humans. They actually affect every type of cell. It's just going to be specific to that type of virus. And so what I really want you to think about when you're reading these first two sections, or if you've already read them, reflect on it, just think about viruses. Like, are they truly organisms? Are they alive? And then also think about the distinctive characteristics. So as I mentioned, there's going to be some very different things that viruses have when compared to other microorganisms that you've learned about, like bacteria or fungi. So think about those different distinctive characteristics. And then I also want you to think about how can something so small and so simple and probably seems insignificant when we really look at just the structure of a virus, how is it capable of causing so much disease and really wreaking havoc on society? I mean, if we look right now, we're in a pandemic. And so we see how impactful a virus truly can be. But it's interesting when you think about this tiny little viral particle and how much damage it can really do. So keep that in mind as you're reading. I also want you to think about how viruses impact our health in ways that we might not expect. So obviously, we can think of the immediate. We catch a virus, we're infected, maybe we have a fever, we have a cough, depending on the virus. Maybe it's a virus that affects our digestive system. And so in that case, what happens? Typically diarrhea, maybe vomiting. There's different impacts that a virus could have on the body and different symptoms. But viruses also impact our health in ways that you might not expect. Like viruses can be connected to certain types of cancer. So someone may have had a viral infection, but that virus has now impacted their health years down the road. And I also want you to think about how viruses have played a role in the development of all organisms. So all of that's going to be covered throughout this chapter, but those are some of the things that I really want you to focus on as you're reading.